So I have not had a chance to check any of the homework. I will do that during class. I'm going to try to get everything done during class, but later on during this class, I'll check the homework. We begin on page 44, so please open to page 44. And while you're doing that, we have a whole ton of announcements to look at. So first announcement, first thing to look at here is just the calendar. So we can start with this one. So today we cover something called lines of best fit. There will be lots and lots of application problems, word problems today, and hopefully we'll be able to make use of all the stuff we've learned about lines as it applies to the real world. So that's the plan for today. Coming up on the horizon, it's not too far away, is our second quest, which is the 25th, which is a week from Monday, all right? 1 week from this coming Monday is our second quest. Next week is a little bit unusual. What happens on Monday? There's a holiday. Monday is President's Day. There are no day classes here at GCC on Monday. Raise your hand if you have a Monday night class. You go to your Monday night class. Monday night classes are on as scheduled, but no day classes. All right, so that is the calendar. Next thing I want to look at involves some of the resources here at GCC and here for this course to help us prepare for quizzes and tests and homework and projects and all that good stuff. So one of the resources that we've mentioned, but maybe a few folks have forgotten about, are the YouTube videos. Michelle, can you say something similar to what you said earlier today about the videos?
Digest it, look at the example. Because at least for me, life goes fast. So be able to slow it down.
Yeah, and I think that that's one of the main features, one of the main reasons I make these videos is that I know that some parts of each class are too fast for some people. Hopefully not the entire class is too fast, but some parts at least. And the nice thing about the video, you can pause it, you can rewind it. You don't have to watch the whole thing. If you have a question today, let's say we're doing something and you have a question and you don't want to pause the class, you don't want to raise your hand and ask it, just take a look at the time. If it's 1:15 when you have that question, just write that down in your packet. Check this video out this afternoon or this weekend. Fast forward to the 1:15 mark of the video. It's really easy to like pinpoint, right? That 1:15 is going to be on the video. So it's very easy to find exactly where your question is. So don't feel like you're going to spend like double the amount of time because you're here in class now and then you're going to watch the entire video. You don't need to. So it's a resource. If you have any questions about how to access it, just ask me. There are instructions in the syllabus. Okay, other resources here at GCC. We have a free peer tutoring program. We haven't mentioned this semester, but it is a wonderful resource free to GCC students. There are lots of hours over here. Generally speaking, Monday through Thursday, 8:30 until 7. Friday is a little bit shorter. There are 6 hours where tutors are available on Saturdays. The Peer Tutoring Center is on the 4th floor in the core, right above the library. You're welcome to just go over there and walk in and say, hey, is there somebody here right now who can help me with Math 106 or any of your other classes? Better is to make an appointment, say I want to talk to somebody about Math 106, and they will find somebody who's available when you're available, and then you'll have an appointment. And if you find somebody that you work well with, you can make a standing appointment where you just meet every week, same time, same place with this person. And I think it's great to do if you're struggling. I think it's great to do if you just want to maintain. You could have like a B+ and go get tutoring. You could have an A and go get tutoring. So for this course, for any course, that's available. All right, as a supplement to that tutoring, GCC is now subscribing to an online tutoring service. It's an off-campus service. It's called Smart Thinking. I'm not really prepared to talk in detail about it right now. All I will say is this: it's a subscription service, but you guys all have a bunch of hours given to you for free because you are students here at GCC. So if you're interested in exploring this online tutoring, just Google Smart Thinking. Notice there's only one T in the middle. It's really Smart Thinking. So Google that. The first link that comes up will be the one that you want. Your username, write this down right now if you're interested, is your GCC email address. The default password which you will change is GCC. Smartthinking.com. Oh, okay, so this was emailed as well. Thank you. So explore. I might come in and give more details about this at another point, but it's free. It's a nice service. There are people available nearly 24 hours a day in a lot of different subjects. So even if you have a crazy work, life, school schedule, you might still be able to find somebody to help you with math or some other subject at 11 p.m. on a Saturday night. All right, I'm happy to email you this document if you send me an email. Next, there is money available, and I'm hoping some of you guys get it. So here's a travel award that is going to be given to some student here at GCC to spend a few weeks this summer learning a foreign language in some other country. There's an application process. It's too small to read. We're not reading this right now. But if you want more details, see me right after class or email me, and I will send you this document. Next, some of you are women in public higher education. There is money available to you. I've highlighted a couple of the important things, $750, $1,000. There's money out there. We're not looking at the details. See me after class if you want them, or email me and I will send you that document. Okay, now finally, there is a ton of money available to everybody, regardless of your gender. If you go to the main GCC page, down here on the bottom right in big letters says scholarships. We'll click on that. And it's going to talk about the GCC Foundation scholarships. This happens every single spring semester. And here's my spiel. There is a ton of money, something on the order of $60,000. I haven't seen the figures for this year, that will be awarded to GCC students in the next month. This is your best opportunity to get some scholarship money. If you are applying for a scholarship at UMass, you are competing with 20,000 other people. If you are applying here at GCC, it's a much smaller pool. There are 2,500 students at GCC. I don't know what percentage of students actually end up applying for these scholarships. I'd be surprised if it was as high as 10%. Most people aren't going to apply. The competition for these scholarships is as small as it will ever be for you guys, and I encourage you to throw your name in the hat. So what does that mean? All right, there are some scholarships that you cannot apply for, but that you can be nominated for by a teacher. So for example, if you are majoring in business, there's some scholarships. Down here, there are some scholarships for music. Here's something for nursing. Lots of different major scholarships. You can't apply, but if you are interested, read through this list. If any of these things sound like you, then talk to somebody in the department and see if they would be willing to nominate you. More important right now for me is the list of the foundation scholarships. This is the stuff that you can apply for. And we're just going to look at a couple of details about a few of these. The 25th anniversary scholarship is based on scholarship, financial need, and character. And there is one award at $800. This is serious money. The Hap Adams Award is based on loyalty, concern, discipline, love, and humility. One award at $275. There are some alumni scholarships. There's a minimum GPA requirement, and you need to be transferring next semester in the fall. And there are two of those awards for $550. We're not looking at all of these, but I just want to give you a sense. There is a lot of money. There are a lot of different awards. Some of them are very specific. All of you are eligible for many of the awards in this PDF. So how do you apply to all of these things? Is it a very onerous? Is it a big burden, the process of applying? The answer is no. So to apply, the directions are right here. Let me make this a little bit bigger. First, the deadline for applications to be submitted is 8 a.m. March 11th, so you have some time. Maybe this weekend you decide you're going to just throw your name in the hat here. There's a common application. Essentially, you're just filling in some basic information about yourself. You need to write a very short personal statement. 250 to 500 words is not long. For many of the scholarships, that is the entire application process. You fill one common application out, you write one short essay, and as you submit your stuff, eventually you'll come to a screen that says which awards do you want to apply for, and you just check the ones that you want to throw your name in the hat for, and that's it. It's not like when you're filling out applications to colleges, it's a different application for every school. This is one application for a ton of scholarships, a ton of money. Some of these scholarships have more stuff that you have to do. You need a letter of recommendation, or you need to write a more specific essay, but a lot of them, it's just very general, very painless. So again, I'd encourage you to think about throwing your name in the hat. There's a lot of money out there and not a lot of people fighting for it. Any questions on that? Has anybody applied to this like last year? Anybody? No. Okay. So first time applicants this year. I'm really hoping a lot of you apply. All right, so those are all the announcements. We come back today on page 44. So we'll go to number 1. And can we start in the back with Drew? Thank you. Davis.
In 1982, 25,000.
Thank you. Let's just take a look at some of the numbers in the table. So what is the first column? Is the year, and you can see the years are progressing as you go down. What's the second column? Percent of fatalities that were alcohol related. Of all the fatalities that happened because of car accidents, these are the percentages that were caused by alcohol. So in 1982, 57% of all fatalities in car accidents were alcohol related. In 1985, it had gone down pretty significantly, 51%. And what's the trend here? All going down, right? We can see pretty readily these numbers are going down as you look down this list. The numbers are all getting smaller. Okay, let's see if we can say any more than that. How much does it go down by in this period right here? That's a down by 6%, right? How about in the next period right there? 1. So now we're not going down by the same amount. This is not a straight line, right? Because the one decrease was 6, but the next decrease was 1. If it was a straight line, it would be a consistent decrease every time. So it's not a straight line. It is down. We probably should also have taken a look over here and made sure that what's happening over there. Yeah, it really, the only thing we could have said about purple is if these guys were all consistent, and it seems like they are, although at the very end, it's a 2-year jump. But it's complicated. It's really hard to look at the numbers in the table and say anything more than it goes down, but not by the same amount every time. So how are we going to get more information, more readable information? Well, we're going to plot the points. And that's what's happened right here. So let's go to Katrina. Okay, so here is that same data, but plotted out. So first, let's make sure we can believe everything that's in this picture. So I'm going to fill this one in, and then you guys are going to fill the other two in here. What's the very first set of numbers in the table, the first row? 1982, and 1982, and then 57%, right? Those are the numbers in the first row. In this table, what's the X value? Is 2. 2 because 1982. What we're saying here is that t equals 0 is 1980. That's where we're starting the graph, all right? And then what's the Y value at that point? It's 57. It's hard to know looking at the graph. I can say it's bigger than 55 and less than 60, but it's hard to know, but it's 57 because I have the numbers in the table. So can you guys go ahead and fill in with your neighbors, check with your neighbors, the points A and B. Find them in the table. You can estimate some maybe from the graph, but then make sure that you agree with what's in the table. All right, so you can estimate from the graph, but you can know what the real numbers are because they're just from the table. And so this first one right here is 1988 and 50%. And the second one is 1999 and 37%. And I contend that looking at the graph, you can get a lot more information than looking at the table. So first of all, is the trend up or down? Definitely down. We could see that just as well as we could in the table. But now we have a much better sense of the rate at which this line is going down. Is it a real steep downhill? No, it's a relatively shallow downhill. I can see the differences that we looked at before. How much was the decrease? The very first decrease in the first two rows was 6%. 6% is exactly how tall that vertical space is. What was the next decrease? Was 1%, which is, I have to try to squeeze here, so that 6% is there. And then the 1% is the vertical space between this dot and that vertical line, which is just a hair underneath it. You can see that if you draw the line between these first 2 points, okay, that's downhill. The second 2 points, not nearly as downhill. You can see the dramatic down in the first one and then just barely down a little bit in the second one. And it's really much easier to read the information when it's presented here in the graph, in the scatter plot, than it is in the table. Okay, let's continue on. We've already done this, label the coordinates of points A and B. Let's go to part B, Aaron. Okay, so looking at the table, again, we said that the data points are generally decreasing, so we could certainly say that. We can also say that the line, the trend is relatively flat. It wasn't a sharp decrease, but it seemed like a pretty shallow decrease. So let's say it's maybe a shallow decrease or decline. And let's go to Dan in the back for part C. Thank you. Okay, is there a line that connects all of these dots? No. So what you're going to draw is like an average line, a line that you think kind of is close to all the points. So take a straight edge. You can use the folder that's on the table or something else, and just draw your best approximation for what you think is the best line, the line that's as close to all the points as possible. And there's a lot of wiggle room here for acceptable answers. Okay, so we've drawn the lines. I'm guessing that no two people in this room have exactly the same line, right? We all had a lot of estimating that we did. I had said there were a lot of acceptable right answers, but there's some wrong answers too. I mean, there's ways to do this wrong. If I drew my line, I think we can do this. If I drew my line here, is that a good fit to the data? No. All right, so don't do that. So we're going to draw something that's downhill. So we'll get rid of that. Okay, so what if I decided I was going to connect the first 2 points here? So I'm connecting 2 points. Is that a good fit for the line? It's not. It's really good for those 2 points and not very good for all the rest of them. So there are some wrong answers, but there are a lot of right answers too. So just ballpark, trying to send something roughly, close as possible to all the data points. Does your line go through any of the data points?
Yep.
For some of you, yes. For others, it's okay if it's a no. Doesn't have to go through any of the data points. But the nice thing about having the line is that you can use the line to maybe get some information that isn't in the table. For example, is the year 1990 in the table? No, 1990 is not there. So we don't have any data for some reason from 1990. But we could use the line to make our best guess as to what the real statistic was back in 1990. What value of t in this graph corresponds to 1990? Is 10. So I'm going to write t equals 10. It's the x value. So I could go to my line, and you can go to your line. You can go to the 10. You can go up to the graph, and you can make an estimate. And so for me, my estimate is, I don't know, 47, 48. Your estimate will be different. Something like that. Does that mean that's what the reality was back in 1990? No. But it's my best guess based on the trend, all of the data and the line that I've drawn up here. And maybe better than trying to get answers that already happened, I could maybe use my line to predict what I expect to happen in 2013, right? We don't have data yet because it hasn't happened. But if the trend continues, I could maybe pick a point on my line that's way out here to the right. All right. So how do we make sure that we're all talking about the same line, because we're just approximated, we just made a guess. So let's go to Joe for number 3. Okay, so I probably should have underlined those because that's some vocabulary there. Linearly related or linearly associated. And I'm going to keep this graph up here, but we're going to ask Sebastian to read the next part, part A. All right, so of all the lines, what's the best one? It's this one. I didn't draw it. You can see that it was already drawn for me. I used some technology to get that thing up there. Hopefully your line is close to this one, but it's not supposed to be perfect because we did an imperfect thing. We just made our best guess. All right, let's go to Michelle for the next part. You note. Thank you. So technology can help you. This was made in GeoGebra. If you're interested in knowing how, see me. It would take probably about 60 seconds to make this thing and have GeoGebra sketch the perfect line, the actual best line. But for right now, we're just approximating, and that's totally fine. So let's keep on going now to the next fill in the blank. How many points are above the regression line? Not the one that you drew, but the one that's drawn for us in this graph. How many points are above the line? 4? Everybody see the 4? 1, 2, 3, and 4. How many are below the line? 2, and it looks like maybe 1 is on the line. Do you think that point, you think this point right here is actually on the line? Yeah, I mean, you can see even like it's just because the dot is so big. I wanted us to be able to see it when I printed this. So that point is not on the line. You can see it. The line doesn't go through perfectly the middle of this point. So probably 3 points are below, 4 are above. And sometimes that happens where it's, kind of a split. It doesn't always have to happen that way. But the point is here, how many of those points are actually on the line? None, right? And so that's an important idea, that the line doesn't have to hit any of the points. It probably won't. Okay, so we're continuing around to Sam. Let's see, where are we? Part B. All right, thank you. So first thing we need to do is figure out what value of t is 1993. Remember, 0 was 1980, so that's 13. So you go to your line at t equals 13, not your line, but the actual best fit line on the bottom of this page. You go to 13 on the x-axis. You go straight up until you find the line. And then where do we go? And then over to the y-axis. We're trying to estimate what number is over here on the left. So you go straight over and you make your best guess. 42, 43, anything in there is fine. So our best guess was that the p was about 42, 43, and we can write a sentence. Here, are we here? So in 1993, we estimate 42% of fatalities were alcohol related. Everybody okay estimating from the line? Everybody okay with the sentence? All right. Move on to Jenny. This process. Okay, thank you. Glenn, C. Okay, so let's go back. We're going to try to pick some nice points that are on the line. So completely ignore the dots. We're only looking at the line. All right. There actually probably aren't any nice points that are on the line, but I can see one that's close. So find a point on the line that's very close to being on the grid as well. Do we see one? Yeah, 16 and then 40. So we're going to pick that point right there because it is very close to being on the grid. It looks like it's actually a little under the grid point, but that's okay. And I don't see a second point that's as nice as that one. So I mean, just looking, I don't see anything else that's really like right there on the grid. 4 and then, okay, so Michelle wants to say this point right here is maybe right in the middle, and it could be. So 4 and 55. What's that? 8 and, so I heard somebody say 8 and 50. I heard somebody say 4 and 54 or 55. Which one is right? Neither of them, but they're both good enough for our purposes. So you just pick something that hopefully is on the grid if you can, because then your estimate is going to be very good. And if you can't find points on the grid, you make your best guess somewhere else. So I don't know which one we want to pick. The first one I heard was this 454. So let's grab that one. So we're going to write the coordinates of these 2 points, both of them guesses, on the next page. So 4, 54. And what was the other one? Thank you. Okay, we'll go to Melanie for D. Wait, where are we? Is there a second D? There might be 2 Ds. Go up higher. Up to there. Sorry about that. Okay, so let's pause. We're trying to find the equation of that line. The equation of the line. In order to find the equation of any line, we definitely need to find its slope. So that's what we're about to do. Armed with 2 points, it's a process. So go ahead and find the slope. I've written the first couple of stages out. We know that the slope is a change in y over change in x. Notice I'm reading that triangle as a change. But let's put the correct letters here. We don't have x in this problem. What do we have? We have t. So downstairs, instead of change in x, should be change in t. Upstairs is a change in p. So go ahead and do your subtraction upstairs and downstairs. Got a couple of blanks here. You're going to get a fraction, and then you're going to get a decimal. All right, so I got something about negative 1.17. I should get 14 over negative 12, and then as a decimal from the calculator. Is that okay? All right, now that we have the slope, step 2, let's find the equation of the line. So we're going to go back to our old friend. What's our favorite equation of a line? Y equals mx plus b. Now note that I've written something here. It says be sure to use the letters t and p instead of x and y. And on the quests and on the tests in the future, I will take points off if you use x and y and the problem isn't x and y. The problem here is t's and p's. Now I'm also going to try to go out of my way to remember to every time say don't use x and y on the test and on the quest. But I'm putting it out there now. Let's go ahead and change. Instead of y equals, what should it be? It should be p equal. Well, we're going to put a number in a second, but I just want to make it p's and t's right now. So you got to know which one is which. Y in this case is p. We knew it from right there actually. T was the first one. So t is like x. P is like y. So instead of y equals, it should be p equals m instead of x, t plus b. I'm guessing that for most people, the first equation is a lot more comfortable than the second equation. Of course, it's more familiar. But if you understand the process well enough, you should be able to do it with any letters. So let's see if we can push ourselves and do it with the letters in this problem. So what we're going to do is replace everything in this equation with some numbers except for the b, the y-intercept. Okay, we can pick either point in green. Let's just pick the same one. Can we pick the first one? 4 and 54. So instead of p, what are we putting? 54 equals, instead of m, negative 1.17. Instead of t, 4. Instead of b, b. We don't know it. That's what we're trying to find. See if you can solve that equation for b. So once you've found the value for b, I got something about 58.68. If I did it right, did I do it right? Yep. I had some questions about this. So I multiplied these two together. That's 4.68, I think. And then how do you move the minus 4.68 over? You add it. So we add the 4.68 to the 54. Yeah, so there's actually a question about rounding here. So let's address that right now. Yeah, so when we wrote this when I wrote negative 1.17, that was rounded, right? And it's fine. And on a test, it's my job to tell you where I want you to round to. I could say nearest hundredth, and that would be the answer. But as soon as you use that negative 1.17 somewhere else, you're going to create more rounding error than needs to be there. So probably better than putting negative 1.17 here would be to have put the fraction. Fractions are perfect. Decimals are rounded. If I had put this guy, the negative 14 over 12 here, turns out we'll actually get a slightly different number. Melanie, what did you say you got? Okay, so it's not off by a lot. It's off by 4/100ths. Yeah, I mean, if you're off by 4/100ths, like you missed the moon by like 1,000 miles, you know, I mean, so like there are reasons to be more accurate. For me, I mean, it's not that big a deal, except there's no reason to create rounding error. And so now I'm adding to the list of stuff I'd like you to be able to do is avoid rounding error. You can round answers, but if you're using rounded numbers, maybe go back up and try to use the unrounded ones instead. Okay, so that means that our equation is, so it used to be over there, the p equals mt plus b. It's still p equals, instead of m, what are we putting? The negative 1.17, we'll use the rounded one there. T, we put in a number for t? Yeah, we did that already. So t is the variable and it's part of the answer here. Plus, instead of b, 58.72, or if you had 68, that's okay too. But there's our equation. Any questions on getting the equation? Lynn, is that all right? Okay. Yeah, there's a video. Okay, let's take a look at step 4. We're around to Ben now.
Step 4. In this case, if you figure out how accurate you were, you get nice points on the line. The equation of the actual line graphed above, where it is good, y equals negative 1.19x plus 58.6.
Okay, that's the actual line that I graphed on the previous page. That's the best line. That's the right answer. Were we close? We were. We said the slope was negative 1.17. What is it really? Negative 1.19. How come we weren't perfect? Was it rounding? Yeah. 4 and 54 is not on the line, or it's not on the grid. It was really hard to estimate. And so, of course, we're going to have some errors. We made our best guess that that was 4 and 54, and our best guess that the point 1640 was on there. Neither of them is on there, but they were close enough that we weren't off by more than a couple of hundredths. So we did fine. All right, so now we've got our line. Let's go on to part D. Adam? All right, so interpreting slope. This is a question that was on our first quest, and it was one of the more problematic questions for folks in this room. So let's see if we can interpret the slope. First of all, anytime you ask me to interpret slope, I need to write down the units before I have any sense of what the answer is. I mean, I know what the slope is. My slope is negative 1.17. But to interpret it, I need to know what the units are. To figure out what the units are, I'm going right back up to my slope calculation here in red. Change in P. What were the units in P? 54 what? 40 what? Percent, right? 54%, 40%. These are percentages upstairs. Downstairs, change in T. What are the units for T? It is years. It's time measured in years. So that negative 1.17 is negative 1.17% per year. Okay, that's starting to get me towards what that number actually means. So I'm going to write that down here. First, we'll write kind of an awkward sentence, and then we'll see if we can clean it up a little bit. So I'll just write the number again, just so we have it. Negative 1.17% per year. Okay, so the percent referred to the percent of alcohol-related deaths. So the percent of alcohol-related deaths changed by negative 1.17% per year. Yeah, and I think that's the less awkward way. To say it changed by negative 1.17, probably we shouldn't say negative in the answer. We should probably say, what did you say went down? Went down by, and then what's the one thing I have to fix? Yeah, get rid of that negative sign. Percent of alcohol-related deaths went down by 1.17% per year. And maybe instead of actually writing this fraction in years, you'd actually write per year. Absolutely. There should be, I won't take off without it, but you're absolutely right. Approximately alcohol-related deaths went down by 1.17% per year. And even that is an average number. There was no consistency in those dots. Sometimes it went down steeply, other times it was shallow. So on average, percentages went down. What's that? You can say either, both, or neither. Saying both is probably the most correct thing we could say. I'm quite happy with what we've got here. I'm happy with what we have in blue. I don't think it's quite in plain English. I think red is better than blue, but I'm happy with either one. Questions on that? So again, any question asking you to interpret slope, first thing you got to do is write the units. That's how we open the door. Okay, next page, part E. Come up here to SevTab. Thank you. So I'm just going to write my equation again here. Oh, that was our estimate. Let's write down the right equation. 1.1, no, it says use yours. All right, let's just write down the one we had. 1.17 t plus 58.72, is that what we had? That's our regression line. That was our best estimate. And we're looking for the percentage. So what letter are we looking for? P. So that's the question. In 1988, which is a value of T. How much is T at that moment? 8 years after 1980. So what do? We plug in. T equals 8, plug it into the equation. Can somebody give me a number here? Anybody else get that? Anybody get something different? What'd you get? 68.04? 49.32? Okay. All right, so we figured out the 68 one. There was all right, so we got to have a negative in front of that number. Maybe that was the mistake. All right, so we'll get rid of that one. What do we think about the other three answers? All very close to each other. They differ because you guys typed in slightly different things. Some of you had 0.68 right there, so that's going to make a little bit of a difference. Some of you probably used the fraction instead of this decimal, 14 over negative 12. That's the best answer. I'm happy with any of these, really. Questions on that? All right, so we're going around to Tenzin. Can you read the synth? Okay, so the original table, can you guys just jump back a page or two? Just go back to the table that we started everything with. What's the first year in the table? It was 1982. What's the last year in the table? 1999. So actually, this is a typo. It should be 1999. So if you are trying to estimate something in between the first and the last, and in this case, we were looking at 1988, which is definitely in between. It's in the middle of the table somewhere, right? Even though it wasn't exactly in the table. Then that thing is called interpolation. If you are inside, inside interpolation. If you are outside, for example, trying to predict in 2002, which is after the last point in the table, then it is called extrapolation. Okay, see the difference? You're in the table, interpolation. If you are outside, if you are extra, outside of, then it is extrapolation. So let's do part F. What value of t is 2002? The 12? 22, right? Years from 1980. Everybody okay getting 22? All right, go ahead and plug your 22 into the same equation that you plugged in the previous problem. All right, so we've got a few different answers here. These two numbers are quite close to each other. I'm sure it's just you started with slightly different equations. This one down here, Sam actually used the right equation, the one that the computer gave me, which is a slightly different equation than the one that we guessed, which is that. So that's why we got that answer. So there you go. I mean, any of them is good. We just have to be clear on what the rules are. 32.45 is the most accurate number up here because Sam used the equation from the computer. On a test, you might not have the equation from the computer, so you might have to use your own. Okay, any questions on that? Last question I have for you, and then it's the group activity. We said down here on the previous page, this was our interpret the slope. The percent of alcohol-related deaths went down by 1.17% per year. Is it possible for that trend to continue forever? No, because at some point, yeah, like we can't get down to zero, right? I mean, at best case, we could get exactly zero if no deaths happened all year that were alcohol-related. We certainly can't get negative, but the line that is drawn here will eventually, off the screen to the right, hit zero and then go negative. So it's only valid for a certain period of time. And at some point, the trend has to stop decreasing by kind of a consistent amount. And you might expect actually, maybe it's something like this where it levels off someplace, but it can't ever get to zero. And it might not even level off at zero. Maybe the best we could ever hope for is like 10%, and it'll never get down below that. I don't know. But it's only valid for certain periods of time. So it's important to make sure that you understand the danger in this extrapolation idea, right? When you use stuff to predict the future, So always a chance that the trends in the past are not going to continue in the future. And we don't have to read all this, but essentially it says that the percentage of alcohol-related deaths stops decreasing by this kind of consistent amount, 1.17 every year. And actually in, what does it say here? In 2002, there were more alcohol-related deaths than there had been 8 years before. So it's not even always going down. All right. So the group activity is in your book. I think a bunch of you have your book here. If you don't have it, probably several people at your table do. But there are 2 examples you're going to find. And I'm highlighting this phrase right here. They are in the right-hand column. It's kind of in the margin on this page. So look very carefully and you will find the 2 problems. Work with each other and I will check homework.